minimize this here. All right. Okay, so my talk's a little bit different. I'm fairly early on in the stage of my development of my model. I'll talk a little bit about the company and sort of the background, and actually maybe Voxel 51 can help me with some of the image analysis that I'm proposing to do with my company. So my name is Dr. Sharon Inch. I'm a plant pathologist with a PhD in botany and over 20 years experience in agriculture research and crop science. Throughout my career, from managing breeding programs to conducting fungicide screening trials, I've witnessed um, firsthand the bottlenecks that slow agricultural innovation. Today, I'm really excited to share with you AgriVision Analytics and how it's transforming plant breeding through computer vision and artificial intelligence. Hopefully, we'll be replacing weeks of manual measurements with instant objective phenotypic data that accelerates variety development and helps breeders respond to climate change with unprecedented speed. Agravision delivers faster, better, and cheaper plant breeding through cloud-based computer vision. Unlike competitors that require expensive hardware, our software will work with any camera, smartphone, drone, or existing equipment, transforming images into accurate, automated measurements. Our platform will link plant traits or phenotypic characteristics with genetic information and family lineage in standard formats that integrate seamlessly with existing workflows, enabling rapid selection decisions without disrupting current systems. Traditional breeding can take 7 to 14 years, but AgriVision's AI platform compresses its timeline by rapidly identifying superior traits and streamlining data analysis. In short, AgriVision empowers seed companies, independent breeders, and research institutions to bring high-performing varieties to market years ahead of schedule, driving innovation, sustainability, and global food security. Next slide. Next slide. Nope. Okay, here we go. So Agravision was founded on a simple but powerful idea to bring data-driven insights to the heart of plant breeding, using image breeders already captured every single day in their existing workflows. Instead of reinventing the process, we're amplifying it. By leveraging computer vision and artificial intelligence, we remove bottlenecks of manual measurements and transform field data into real-time actionable intelligence. Breeders can go from raw images to quantified traits, plant height, canopy area, fruit count, disease severity, all in hours and not weeks. Imagine walking through a trial field in the morning, capturing images with a smartphone or drone, and by afternoon, seeing those images converted to action. Sorry, my dog is barking here. Seeing those images converted into accurate, standardized data ready for selection and analysis. This is where AgriVision changes the game. Our platform doesn't require specialized camera, complex installation, or major system overhauls. It is designed for simplicity, accessibility, and seamless integration with the tools breeders already use. At its core, AgriVision delivers 3 transformative advantages: speed, accuracy, and scalability. By accelerating data collection and improving precision, AgriVision empowers breeders, identifies superior genotypes faster, making data-backed selection decisions and bringing climate-resistant, high-performing varieties to market in a fraction of the time. So the plant breeding industry is facing a critical bottleneck. One is that slowing innovation, increasing costs, and limiting our ability to adapt in the face of global climate change. Traditional breeding workflows are painfully time-consuming, resource-intensive, and heavily dependent on manual labor. Every growing season, breeders walking through fields, counting flowers, measuring plant height, and recording data by hand, often across thousands of plots under unpredictable conditions. It's a process built on dedication, but not efficiency. Here's what they deal with today. Manual scouting that takes weeks, sometimes months, to complete, leaving breeders struggling to process and analyze results before the next planting season even begins. We have inconsistent data collection plagued by human error, variability, and delays. And perhaps the biggest challenge of all is variety development that takes 7 to 14 years to bring a single new crop to market. That's an entire decade of investment before farmers see results in the field. Meanwhile, climate change continues to accelerate. Breeders face shorter seasons, unpredictable weather, and emerging pests and disease that demands rapid adaptation. All of this is happening while global food demand is rising, and the pressures to produce more with fewer resources has never been greater. The truth is, these manual analog processes can't keep pace with the scale of the changes that we now face. So it's Time for AI-driven insights and breeding, faster, more accurate, and data-rich decisions that empower researchers to focus on discovery, not data entry. And that's exactly what Agravision is proposing to deliver. So before diving into our solution, I want to frame the urgency of this challenge. By 2050, the global population is projected to reach 9.7 billion people. That's a 70% increase in food demand compared to today. At the same time, climate change is already reducing crop yields by 10 to 30% in vulnerable regions, while emerging pests and diseases threaten production stability. We also are facing severe resource constraints. Arable land is shrinking, water availability is declining, and the traditional breeding timeline of 7 to 14 years per variety simply cannot keep pace with these accelerating challenges. This isn't just an academic problem, it's a global food security crisis. Breeders need tools that compress development timelines to 2 to 4 years so they can rapidly deploy climate-resistant varieties. That is the gap that AgriVision Analytics is designed to fill, giving breeders the speed and precision they need to respond to these urgent challenges. So here's a high-level overview of traditional breeding workflows. After crossing and planting, the researcher spends weeks, sometimes months, each season manually phenotyping. This means counting flowers and fruits, measuring height, leaf area, or yield components, and recording every single observation by hand. This is where most of the time and resources are consumed. And even after all that effort, breeders still face data gaps and inconsistencies. Measurements taken under different lighting, weather, or growth stages that make side-by-side comparisons difficult. Then comes data entry, another layer of delays and potential errors, as handwritten notes and spreadsheets have to be cleaned, formatted, and verified before analysis can begin. In many programs, this manual cycle repeats across hundreds or even thousands of plots and multiple years of field data. The result? Critical decisions get postponed, resources are stretched thin, and the full breeding cycle from the initial cross to the released variety can take up to 14 years. In a world demanding rapid adaptation and faster innovation, this pace simply can't keep up. So let's quantify the bottleneck. In a typical breeding trial of about 10,000 plants, breeders spend on average about 3 full weeks of continuous field scouting. That means walking row by row under high heat, humidity, and unpredictable weather, manually recording traits like plant height, flowering time, and disease severity. Even with experience, the process is extremely subjective, and studies have shown that different observers can vary by as much as 25% in their measurements. That is 1 out of every 4 data points potentially inconsistent, introducing noise right at the foundation of your breeding decision. And it doesn't end there. After the fieldwork, data entry and cleanup can take another 1 to 2 weeks, checking spreadsheets, verifying labels, and standardizing file formats just to make the data usable. In total, more than half of the breeding program time is tied up simply in collecting and organizing data. That means less capacity for the real value, analyzing genetic patterns, exploring new traits, or identifying climate-resistant candidates. So even before a breeder can test a new line or run a genetic model, they've already spent weeks in the field and keyboard just trying to capture basic measurements. This is the inefficiency Agravision is built to solve, freeing scientists to focus on discovery, not data wrangling. So the solution Agravision Analytics provides is a cloud-based computer vision for accelerated plant breeding. Our platform is based on 3 core pillars, the foundation of how we bring automated precision and scalability to breeding programs worldwide. First, any camera technology. We work with what breeders already have, smartphones, drones, or existing imaging systems. There's no need to buy expensive proprietary hardware. You can start simply with a smartphone photo and still generate accurate quantitative measurements. As programs grow, breeders can easily scale up, adding thermal, multispectral, or hyperspectral sensors to capture richer pictures of plant health, water stress, and nutrient use. The goal is flexibility and accessibility. Whether you're a small research team or a global seed company, Agravision meets you where you are and grows with you. Second, and most importantly, genetic linkage. Most phenotyping tools simply give you trait measurements. Agravision goes further. We link plant characteristics directly with genetic information and family lineage in a unified digital system. That means when you identify a plant with superior yield or fruit count, you can immediately trace its genetic background, understand which parents contributed to those traits, and make data-driven selection decisions in real time. We deliver the complete picture: phenotype, genotype, pedigree, and environment, all integrated into one platform, accessible through the cameras you already own. The results: breeders can make faster, more confident decisions based on not just what they see in the field, but on the genetic data driven those traits. Third, we have seamless integration. We all know that breeding programs already rely on existing software ecosystems. So we're going to design Agravision to integrate effortlessly with those workflows. No need to rebuild or retrain. Our data flows directly into existing database and analysis tools and visualization dashboards. Using standard interoperable formats, we transform weeks of manual measurements into hours of automated analysis, delivering data that's not only faster, but more consistent, reproducible, and scientifically robust. So whether you're tracking thousands of breeding plots or mapping complex trait interactions, Agravision will give you the clarity, speed, and precision to make informed decisions and bring superior varieties to market years sooner. Our value creation process accelerates crop innovation through intelligent phenotyping across 3 customer segments. First, independent seed companies. These are agile innovators working to bring regionally adapted varieties to market faster than their large competitors. Agravision helps them scale precision phenotyping without massive infrastructure costs, giving them access to the same AI-powered analytics as global corporations. Second, government and academic breeding programs. These institutes are driven by public good research, developing climate-resistant crops, nutrient-efficient varieties, and solutions for smallholder farmers. By integrating Agravision, they gain standardized, shareable data sets that accelerate collaboration across universities and research networks. And third, we have specialty crop breeders. These teams work with high-value crops like fruits and vegetables and nuts, where visual quality traits such as color, size, and uniformity are key drivers of success. Agravision image-based analytics will allow them to measure those traits objectively and make faster, more confident selections. Across all 3 segments, our workflow is streamlined and repeatable. We have image capture, AI processing, data analytics, breeding insights, and finally, platform delivery and success. Each step is designed to eliminate inefficiencies, enhance data accuracy, and produce actionable insights that drives faster, better, and more informed breeding decisions. The result: every customer, whether academic, commercial, private, gains a unified intelligence system that transforms field images into predictive insights and accelerates innovation from plot to product. So here's sort of how I'm going to structure the data and the modeling system. It's, again, very preliminary. So at its heart, the YOLO V8 models for object detection and segmentation. These models will hopefully identify and isolate individual plants, leaves, and fruits with pixel-level precision. Once the images are processed, regression models step in to estimate biomass, predict yield, and generate quantitative metrics like plant height, canopy area, and fruit count, all automatically. Images can be uploaded directly to the cloud or processed locally through our offline Edge module, perfect for field sites with limited or no connectivity. That means breeders can keep collecting data even in remote or resource-constrained environments. On the back end, Agravision will hopefully run on a secure AWS-hosted microservices orchestrated in a Cubase cluster that auto-scales to handle thousands of images per hour. Every component is optimized for speed and resilience. So whether you're processing a few dozen images or entire season's worth of data, the system scales seamlessly without downtime. All data will be protected with end-to-end encryption, ensuring confidentiality, integrity, and traceability from image capture to analytic output. Integration is frictionless. We expose RESTful APIs and support standard data formats like BR API, JSON, and CSV. So breeders can plug Agravision directly into their existing database breeding tools and analytic pipelines. In short, Agravision architecture isn't just faster and secure, it's built for interoperability, scalability, and scientific rigor. That's what makes our technology field ready, cloud smart, and the future proof for the next generation of crop innovation. So we're targeting an 18.8 billion global plant breeding market, which is projected to reach about 62.8 billion in 2030. That's a 12.8 compound annual growth rate, an enormous expansion driven by rising food demand, climate pressure, and the urgent need for faster, more precise innovation in agriculture. Within the global landscape, our primary focus is on cereals and grains, the backbone of food security worldwide, representing $8.46 billion dollar market, or roughly about 45% of the total market. Our secondary focus is on specialty crops, fruits, nuts, and vegetables, which is a $1.88 billion segment that's growing rapidly due to consumer demand for quality, nutrition, and sustainable production. We are also strategically positioning within the biotechnological breeding technology segment, which itself is projected to grow from 12.2 billion to 30.4 billion in the next 5 years, or by 2030. So that is the space where innovation is accelerating fastest, combining genetics, phenotyping, and data science to bring breakthrough varieties to market years ahead of the traditional market. If we look at the addressable market funnel, we see that the total addressable market, or TAM, stands at 8.8 billion. The serviceable addressable market, or SAM, our realistic reach within that global space, is 4.7 billion. And the serviceable obtainable market, or SOM, is our near-term attainable slice, which is estimated about 470 million. So even capturing a small percentage of that market represents a tremendous opportunity because our software module scales easily. Every new breeder, region, or crop type added increases recurring revenue without proportional costs. So this is the market where data, speed, and precision define competitiveness, and Agravision's positioned right at the intersection of all three. So how does Agravision stand out in what may seem as a crowded ag tech space? It comes down to 6 key differentiators that together make our platform uniquely scalable, flexible, and future-ready. First, scalable cloud architecture with offline mode. Agravision is designed for real-world conditions. Breeders can collect images and data even in remote or low connectivity locations. The system operates fully offline in the field and automatically syncs once connection is restored. This means zero downtime, uninterrupted productivity, and reliable data capture no matter where you're breeding, from greenhouse benches to rural test plots. Second, hardware flexible AI platform. Unlike legacy systems that lock users into proprietary cameras or sensors, Agravision is hardware agnostic. It works with any imaging equipment, so smartphones, drones, or existing research cameras. Breeders can start with the tools they already have and own and scale up later with multispectral or hyperspectral sensors as their program expands. We have no lock-ins, no barriers, just flexibility and freedom to innovate. Third, rapid real-time analysis. With Agravision, what once took weeks of manual measurements now takes hours. Our AI delivers near instant results from image to insight, allowing breeders to make faster data-driven decisions while the plants are still in the field. That agility at the speed of science. Fourth, we have modular API first design. So Agravision is going to be built to integrate, not replace. Our API first architecture connects seamlessly with existing breeding systems, LIMS databases, and analytics dashboards. That means breeders can plug us into their workflows without retraining teams or overhauling infrastructure. Integration, not disruption. That's our philosophy. Fifth, we have cost-effective subscription and use pricings. We're making advanced AI accessible. Our price model combines affordable subscriptions with flexible usage tiers that fit small research teams as well as multinational programs. The goal is to democratize digital breeding, putting powerful analytics in the hand of every scientist, not just the largest corporations. And six, seamless phenotype-genotype interactions. Again, this is where we kind of stand out from some of the other companies. This is where Agravision, again, is just truly kind of a new sort of groundbreaking tool that breeders can use. So we're the only platform that directly links what you see in the field, the phenotype with the genetic data driving those traits. That connection turns every image into a discovery engine that helps breeders understand performance, predict outcomes, and accelerates genetic gain. So the unique combination of simplicity, integration, and speed is what truly sets Agravision apart from legacy providers who force breeders to adapt to their rigid systems. With Agravision, breeders don't have to adapt the software adapts to them. So I'll go through my phase sort of my sort of vision of how this project will roll out. So our go-to market strategy is a rapid pilot to scale rollout designed to build momentum, credibility, and market presence in 4 clear phases. So phase 1 is product development, and that's currently where we're sitting, is developing the models themselves. So we're building and refining our core software architecture and training our computer vision and AI models across diverse crop data sets. This phase ensures that Agravision is field validated and scientifically robust before wide-scale deployment. We're working closely with research partners, which we're identifying, to collaborate with models, validate accuracy, and ensure interoperability with existing breeding databases. The outcome of phase 1 will be a production-ready platform that breeders can deploy confidently across field and greenhouse environments. Phase 2 is our pilot program. Here we'll engage at least with 5 different key breeding partners across both private and public sectors, including seed companies, universities, and government research stations. Each pilot will serve as a proof of value environment where we demonstrate measurable time savings, data accuracy, and economic return. These partners provide both validation and visibility, positioning Agravision as the trusted solution for intelligent phenotyping. Third phase will be a regional expansion. Once we've proven value through our pilots, we'll move to regional rollout across North America, which includes scaling deployment with large-scale seed companies and breeding organizations, establish reseller and chain partnerships, and integrate our platform with existing ag tech ecosystems. We'll also expand our support network, onboarding agronomists and technical specialists to ensure rapid adoption and customer success. And then phase 4 finally is the market dominance. So we hopefully will position Agravision as the standard for digital phenotyping, driving adoption through case studies, publications, conference presentations. Our strategy focuses on building credibility and references at every stage. So by the time we reach full scale, Agravision is recognized as the leader for AI breeding intelligence. I'm going to skip through these couple of slides to leave some time for questions. So our business model is built for scalability, predictability, and long-term customer value. At its core, Agravision operates on a recurring revenue model with flexible value-based pricing designed to grow alongside our customers. We generate revenue through 3 primary streams. First will be software as a service subscription, so the customers can subscribe as either a per user or per site basis, giving them access to our full suite of computer vision and AI analytic tools. This tier pricing model allows smaller breeding programs to start at an accessible level, while larger enterprises can scale up across multi-research sites or international operations. So it's flexible, transparent, and sustainable, ensuring continuous revenue while adapting to the customer's pace of growth. Second source of revenue will be onboarding and integration fees. Each new customer engagement includes customer setup, data mitigation, and training for staff and researchers. These onboarding services generate immediate revenue while ensuring adoption and smooth transition to AI-powered workflows. It also deepens customer engagement early on, turning first-year users into long-term partners. And thirdly, we'll have a premium data insights package for advanced customers who we offer high-value analytics and support packages that extend beyond phenotyping. These will include cross-trial performance analytics, predictive modeling, and yield optimization dashboards, features that'll help breeders strategically make decisions faster with greater accuracy. These premium tiers will deliver higher margins and demonstrate Agravision's position not just as a tool, but a full intelligence platform for modern breeding programs. Okay, sorry, I got 2 screens here. Okay, so I talked a little bit about what the initial plans are, and then so for future R&D pipelines, we have a couple different additional features we want to integrate in there. First would be the advanced genomic prediction models, basically integrating dense genetic marker data with our phenotypic measurements to create a truly predictive engine for plant performance. By linking genotype and phenotype in real time, breeders will be able to forecast trait outcomes before even field trials begin. This means, again, faster selection cycles, dramatic reducing cost, and a path developing climate-resistant varieties in years instead of decades. Second, we'll have the multispectral and hyperspectral image modules. I'm not going to talk too much about those. Also, we want to integrate some root and canopy phenotyping in 3D using LiDAR and stereo vision technologies. And fourth, automated disease scoring models. So hopefully with our AI algorithms, we can deliver objective, repeatable quantification of pathogen symptoms, eliminating human error in resistant breeding programs. We'll standardize image capture and analysis so breeders can compare disease response across trials, locations, and years with unprecedented consistency. So this will save time, reduce subjectivity, ensure that the best lines are advanced with data-driven confidence. And then finally, one of the other things I'm really interested in is developing the integrated pest and crop health monitoring system. We're so basically expand beyond the breeding and look at the developing automated modules for insect identification and counting. These tools will use the same core vision technology to deliver field-ready IPM solutions, helping growers make faster, more informed decisions on pest pressure and intervention timing. And because this initiative leverages my background in plant pathology and pest detection, it's a natural extension to Agravision's expertise. So we are currently seeking investment and collaboration. So I'm currently writing a few grants proposals through USDA and SBIR grants, as well as looking at investors as well. We're also looking for technical collaborators, so AI, machine learning specialists, computer vision engineers, full stack software developers, and cloud infrastructure architects and DevOps engineers. So that's obviously not my area of expertise. Again, I'm a plant pathologist and trying to learn a lot of this AI machine learning and how to apply it to sort of real world problems. And then domain experts, so plant breeders, agronomists, data scientists, business development, sales professionals, and regulatory IP specialists. And so with that, hopefully if this vision resonates with you, whether as an investor, collaborator, or research partner, I'd love to continue the conversation. And so for more information about partnership opportunities, you can reach me here at sinch@cropspectra.com. There's my telephone number as well. And so hopefully together we can build the future of agriculture, one data-driven breakthrough at a time.